students, hope you are enjoying our online lectures. So students, today we are going to start with a new chapter, work and energy. And under this topic we are going to study about the concept of work done and the types of work done as positive work done, negative work done or zero work done. So before starting, let's look upon the learning outcomes of the day. Students, after the completion of the topic, you will be able to define the scientific concept of work done, correctly identify the work done from the given situations, means whether the given under given situation the work is done or not done, and enlist the formula for the work done. Then you will be able to apply that formula in the given numerical problem. And last, you will be able to differentiate between the positive and negative work done. Under what conditions the work done is said to be positive and under what conditions the work done is said to be negative. This you will be able to differentiate. So students, before starting with the chapter, let's look upon that what does work mean to you. Are you doing the work when lifting weights or walking with a big bag of grocery in your hands or completing your home assignments, homeworks or writing an essay? We call them as the work as in day-to-day life. है ना? But actually the meaning of the work is different in the scientific concept. Actually, when we consider the work in terms of physics, then the meaning of the work is entirely different here. It's not like writing or reading or learning something. So, what is the meaning of work done? Scientifically, work is done only when a constant force applied on an object causes the object to move in the same direction as the force applied. Means here the two physical quantities are involved. That is, number one is the force and the number two is the distance covered by the object. Okay? So scientifically, work is the concept when there is force and displacements are involved. Means the object is moving, means displacement is there and we are applying the force on it. So I hope it's clear that scientifically we say work depends upon two physical quantities. Number one is force and number two is the distance or the displacement, because we are talking of the movement in the same direction. Okay? So what we consider the work is done in physics language, we say when you push a heavy shopping trolley for 10 meter. Means here two things are involved. You are pushing means you are applying, yes, force, and trolley for 10 meter means the trolley is moving for 10 meters. So you are applying the force as well as the movement of the trolley is there. So it is considered as work done. Secondly, when you lift your school bag upward by 1 meter. Here also you are lifting. Lifting means you are applying the force on the school bag and it is moving by 1 meter. That means there is distance covered, moment is there. So we consider this as the work done. Okay? Now what we not consider the work as to be done is, number one is when you push against the wall. Yes, here you are applying the force. No doubt you are applying the force on the wall. But is there any displacement of the wall? Yes? No. Means the force exerted by the man on the wall does not do any work, because that force does not cause any displacement in the wall. Okay? So there is no work done. Although you will get tired by pushing the wall, but scientifically work done is zero. jumping continuously at the same spot. If at the same spot you are moving up and down, no displacement is there, you are on the same spot, so no work is done. Holding a chair, walking around the classroom, means while holding the chair you may be tired. You can say I am doing lot of work in holding the chairs, but scientifically the work done is zero, because you are just holding the chair and you are not taking it anywhere. Okay, so in the terms of physics, when we consider the concept of work, then we can calculate it by using a formula. So it can be calculated by using this formula: work done equals to constant force multiply the distance moved in the direction of force. Please see here, the distance should be in the direction of force. Means when we apply the force and the object is moving, the object should move in the direction of force. Then that force and that distance when multiplied, then it gives us the work done. Okay, so we can write W for work done and for the force F, and the displacement is written by symbol S. So work done can be written as W equals to F into S. And if we write the SI units, the work done, the SI unit of work done is joule, and it is same as joule is same as when force of 1 Newton displaces the object by 1 meter. Then the work done is 1 joule. Clear? 1 joule is the work. Yes. When force of 1 Newton displaces the object through 1 meter in the same direction. Okay? Now students, work is a scalar quantity, but it can be positive or negative. Okay? It does not have any direction, but it can be positive or negative. It all depends upon this direction. Direction nahi beta. It all depends upon the angle of force with displacement. Means you can see here the four situations. Number one, in this first situation, you can see the car is moving horizontally. This D is showing the direction of the distance covered by the car, and this rope, yellow colored, this is showing the direction of force applied. You can see here force is applied at an angle, not in the direction of displacement. It is at an angle. So we have to consider the angle between the force and displacement, so that we can find that what is the component of the force in the direction of displacement. We have to find that. No doubt it's a little bit new concept for you, but we will consider that what is the angle between the force and distance, and then we can find the force in the direction of displacement. Very easy concept, I'll tell you how. Now you can see here the angle between the force and displacement is more than 90 degree. It is obtuse angle, you can see. And in the second case, force is applied here in this direction and displacement is in the right direction like this. They are making the acute angle. So angle between them is less than 90 degree in the second case. In the third case, you can see the force is applied in this direction, but car is moving in this direction. You can see the angle between them. This will be the obtuse angle. Force is along this direction and displacement is here, so angle will be more than 90 degree. Similarly here, force is applied at this angle and object is moving horizontally, so angle between this force and displacement is more than 90 degree. So just see, there are different situations where force and displacement are not in the same direction, rather they are making certain angles. Okay? So there will be another formula for writing the work done. Firstly, what we have done is, we have done that work done is written as F into D, force into displacement, या F into S या F into D. But whenever force is applied at an angle to the displacement, if this box is moving horizontally and the force is applied at an angle, it is not horizontally, then beta we have to consider the angle of this force with the horizontal direction. And we here introduce the new term, that is cos theta. Okay, so theta is what the angle which this force makes with the direction of displacement, and cos is the trigonometric ratio. बेटा इसके लिए आपको सिर्फ और सिर्फ you have to memorize this formula and only the few values of cos theta. ठीक है, so the work formula for work done will be now W equals to F into S but multiplied by cos theta. F into S तो हमने कर लिया, लेकिन here new concept cos theta will be here. This theta is the angle between the force and the direction of motion. And beta for cos theta you have to memorize only the three values. One is cos of 0 is 1, means if this force and this displacement both have the 0 angle, means force is in the direction, then we call the angle to be 0, and cos of 0 is 1. This just memorize this, cos of 0 is 1. Okay? And when force and displacement are at 90 degree to each other, we will consider this example in the further slides. So when the angle is 90 degree, means object is moving horizontally and force is applied vertically. The angle is 90 degree. Then cos of 90 is always 0. There is no work done at that case. We will consider this example ahead. ठीक है, बस याद रखना है cos of 90 is 0. ठीक है, and the last cos of 180 degree means when force and the displacement they are making the angle 180 degree, means object is moving towards right and force is applied towards left. It can happen. We'll consider the example. ठीक है, जैसे gravitational force को देखो, if you are lifting certain object upward and gravitational force is acting downward, that means gravitational force is acting downward and object is moving upward, so angle is 180 degree. So you have to memorize cos of 180 is minus 1. Okay, just remember this block, read block, write in your notebook and just memorize this. Okay, so we have done the two formulas for the work done. Number one, work is equal to force into distance or displacement, and second is if the force and distance are not in the same direction, then we consider the formula W equal to F into S into cos of theta. ठीक है, and cos के लिए हमें तीन values learn करनी है, cos 0 1, cos 90 0 and cos 180 minus 1. On the basis of these three, we make the work done as positive, negative or 0. Let's see how. Students, as we have seen, if the angle between the force and the displacement is theta, then work done is written as F into D or F into S into cos theta. Okay? So let's consider the three examples. When the angle between the force and displacement is acute angle, then we call work done to be greater than 0 and we call it as positive work done. Okay? When the angle is 90 degree, then we call the work done to be 0. And when the angle is more than 90 degree, that is obtuse angle, then work done is considered to be the negative. ठीक है, हमने एंगल को देखना है. If the angle is less than 90 degree, 0 to 90 degree, then work done is always positive. If it is 90 degree, then work done is 0. And if it is greater than 90 degree, then the work done is negative. ठीक है, so this question is also there in your NCERT back exercise, that what is the work done in the three cases. So first case देखो, force is vertical and displacement is horizontal, means work done will be 0. कैसे? Because the angle between F and D is 90 degree. Both are perpendicular to each other. So angle is 90 degree. So हमने अभी भी सीखा cos of 90 is, yes, याद है, cos of 90 is 0. So work done is 0 in the first case. ठीक है, if we put cos of 90 0 here, so this work done will be 0. ठीक है, if force and displacement are in the same direction, means angle is what? Yes, 0 angle. तो cos of 0 is 1. ये भी याद किया है हमने. So this will be the one factor. So work done will be simply multiplication of force and distance. This will be 1. ठीक है? So work done is positive. But if force and displacement are in the opposite direction to each other, that is like here you can see, then angle is here F and D का angle कितना है? It is, yes, it is 180 degree. So अभी हमने learn किया है cos of 180 is -1. So work done will be negative. ठीक है? So when the work done positive, when the work done 0, and when the work done negative, you can see from this example. ठीक है dear? So let's discuss certain problems based on the work done or not done. Let's consider who has done more work. Here you can see this person is pushing this ball of 300 kg, but for 10 seconds he is pushing and applying 500 Newton force, but there is no movement. You can see here there is no movement at all. Means, is there any displacement in this case? Yes, students? Is there any displacement in this case? The answer is no. There is no displacement at all. Okay. So we will say that work done is not here, not done. Okay. But in the second case, you can see here the boy is pushing this ball of 100 kg by applying 500 Newton force and covering the distance 6 meter, and he is applying the force for 5 seconds. So you can see here that in the first case there is no work done. Here you can see there is no movement. So yaad hai formula? Yes, W equals to F into S into, yes, cos of angle. ठीक है? तो यहाँ पे what is happening is force is horizontal and movement is not at all there. Means F is there but S is not there. So W will be equal to 500 Newton force multiply this distance is not there at all. We will take it as 0. Multiply angle तो कोई कंसिडर ही नहीं करेंगे, कुछ पता ही नहीं डायरेक्शन का. सो दिस जीरोस हेल्प अस टू आंसर दिस क्वेश्चन दैट W is equal to 0. This displacement is 0, so work will be 0. But here you can see F is there 500 Newton, displacement is there 6 meter, and both are in the same direction. F is also here in this direction, S is also here in this direction. So angle will be, theta will be 0 degree. And what is cos of 0? Yes, it is 1. So work will be there. So work done F into S into cos of theta. So force is 500 and displacement is 6 and this is 1. Cos of theta, cos of 0 is 1. So answer will be 3000 joules. ठीक है जी? So you can see here in the next slide it is solved. We know that work is equal to force into distance, and here I have already discussed that here the distance is 0. So you can see here in the first case work done is 0 joule, and in the second case it is 300 joules or 3 kilojoule you can write. 1000 means kilo. Okay? So let's consider the more examples of work done. Here you are helping to push your mother's heavy shopping cart with a force of 15 Newton. Here the force is 50 Newton for 200 meters. There you can see here students, force is also there and the displacement is also there. What is the amount of work done? So very simple, work done is force into distance, as it is clear here that the both force and the distance are the same direction. There is no angle given, so we'll take as only the formula as F into S. Just multiplying and you get 10,000 joule is the answer, or 10 kilojoule is the answer. You can write this question in your notebook also. Okay? Let's consider another example of work. Jack put on his backpack of weigh 120 Newton. ठीक है? Then he starts running on the level ground. ध्यान से देखना है एंगल को हमने. ठीक है? For 100 meter. Before he started to climb up the ladder, up to the height of 10 meter. How much work was done? Students, here you can see that from the physics point of view, no work is done when on the pack at the level ground. Means when he is running, then this way is acting, this direction of weight is acting downward, and he is running horizontally. So angle between them is, yes, it is 90 degree. Okay, so cos of 90 is 0. The reason is lift is perpendicular to the movement. He is lifting, that is vertical direction, and the movement is horizontal, so angle is 90. So there is no work done. So work is done only when Jack is climbing up the ladder, because that force is also along the vertical direction, and he is also climbing in the vertical direction. So work done will be F into S, that is 120 into 10, that is 1200 joules. Okay, students, weight is 120 Newton. Okay, so answer is work done is 1.2 kilojoules. So student, that was all for today, and in the next topic we are going to discuss about the concept of energy. So just see here, as we already know that energy is just the capacity to do work. Means we have done the work, and the work कितना होएगा, कितनी capacity है हमारी work done की, that is determined by the energy. So units of energy is same as that of work done, that is joule, and different forms of energies that we have already studied in the junior classes also, like kinetic energy, potential energy, electric energy, chemical energy, solar energy, nuclear energy, light energy, है ना? But in this chapter we are going to concentrate more on the mechanical energies, that is this potential energy and the kinetic energy. Okay, so let's conclude for the day. What we have done is we have done the meaning of the work done and the formula for the work done. Like first formula we have done that work equal to force into displacement, and secondly we have done work equal to force into displacement, but the angle also considered cos of theta. And for the cos we have learned the three values. Cos of 0, then it will be just consider as 1, cos 0 is 1. So work done will be simple F into S. Okay. Cos of 90 is considered to be the, theta is 90 degree, then cos of 90 is 0. So work done will be 0 degree. Okay. And cos of 180 degree is considered as negative. So work done will be W equal to minus of F into S. That is negative. Okay, beta. Thank you class. Thank you for the day. Thank you and have a nice day.